Hey, what's up? The Cabinet Vision guy here with another video podcast. In the last video, we went over the differences between Cabinet Vision Solid Essential and Cabinet Vision Solid Standard. Now, I was helping out Mark B at moderndesigns.inc.com by explaining, in a very general sense, how to add these type of extruded pulls to his doors in Cabinet Vision. Now, I wanted to go over Cabinet Vision Solid Advanced, but I also wanted to show off how I would do this. Then I realized I can kill two birds with one stone here. Because of how I would accomplish this, we would need a base Cabinet Vision level of Advanced, which is the very first version of Cabinet Vision Solid that gives us the ability to do the following: import SketchUp models as parts, store parts into a part library, and create user-created standards. Now, not only will we be able to use these features to accomplish this, but it's going to show off the next big step between the standard level of Cabinet Vision and the advanced level. On top of that, it's a good way for me to show off some UCS stuff. Before we start though, I had to do some research to figure out more information about this pull, which, thankfully, Mark let us know that it's made by Epco, which allowed me to go to their website and find this, the Epco DP414, which, as near as I can tell, is the pull that Mark is showing us in his post. This is great, because Epco gives us just enough information, if I scroll down a little, to make this pull in Trimble SketchUp. Since we aren't going to be machining this specific object, all we need is the overall height, the overall width, and the distance of the top of the pull to the bottom of this mounting piece. Since we have all of that, I can just slide this window here off to my other monitor, because I want to keep it open so that I can reference those dimensions later. Now, I already have Trimble SketchUp open, so we can start drawing right away. The first thing I want to do is go to the front view, so I go to Camera, View, then Front View. You'll see why I want this in the front view later in Cabinet Vision. Next, we need to draw our base rectangle. So I select my rectangle tool from my tool palette and start here at the global 0 point. Then I drag the rectangle out in the direction that I want, which is up and right. And now I can just use my keyboard to enter the exact dimensions that I want. In this case, it's 7/8, a comma, then 1.75 or 1 3/4. Either way is fine. Finally, I just have to press enter on my keyboard. So now I have my base rectangle. Next I want to draw the outline of my extruded pull. To do that, I want to place some guides that I can use to get these lines in the proper place. Now, if you don't have this huge tool palette here, you can open it up by going to View, select Tool Palettes, and then making sure that your large tool set is enabled. I'm going to start with the extruded material thickness. Since Epco didn't give us those dimensions, we're just going to assume that the thickness is 1/16 of an inch or 0.0625. So we can click on our rightmost rectangle side and slide the guide tool over, then use our keyboard to enter 0.0625 and then press enter. We'll do the same for the top. Now we need to get that little bottom seating area where the pull will sit on top of the door. Since we know the overall height and the pull's top height, we can use some math to figure out that from the bottom of our rectangle to the bottom of the seat is 13/16 of an inch, or 0.8125. So we can, with our guide tool selected, select the bottom side and drag up, then enter 0.8125. We still need a little material thickness, so we'll make another guide 1/16 of an inch above that. Now let's go ahead and draw our first profile line. This line will let us delete the bottom two rectangle sides by clicking on them and pressing delete on our keyboard. We know that we are working with a properly closed geometry because we didn't lose all of the faces, just this smaller rectangle that we didn't want anyways. Next, we will place another guide from the leftmost side about 1/8 of an inch, since we saw from our image that the lip for this pull is obviously thicker than the rest of the material. Now, one more guide, the one that defines the lip's depth. We'll make that 1/8 of an inch as well. Once again, we can start drawing another line to finish our profile off. Once that's done, we just delete this extra line and voila, we have the profile shape we need. I'm going to delete the guides and then draw some dimension lines just to verify that we have the dimensions that we need. Excellent. I can delete those dimensions and then just use my push-pull tool to extrude out this profile. We don't need a big profile, just enough to have a full solid model. So let's just make it a simple 1 inch deep. After we check it to make sure it looks good, we just need to save it to a location that Cabinet Vision can find the SketchUp model at. Cabinet Vision is on my Windows computer, connected to my network, so let me just put it on that computer. And now we can switch over to Cabinet Vision. What we have here is the finished result. You can see that I have an extruded pull on the drawer and one on each door. This may not be where you want them, but for the purposes of this video, it's where we're going to place them. The knowledge that you gain here should help you make adjustments to place them where you need them. Now, here's the best part. I don't have to do anything with them anymore. The logic that we're going to add will make the parts follow everything exactly as it needs to. So, for instance, if I go to the section view, double-click on my doors, and then open them up, we can see that the pulls follow the doors like they should. Now, I'm in the ultimate version of Cabinet Vision, so I'm going to do a quick transition over to advanced. The first thing that we want to do is create a new part, so we need to open our part catalog. The part is going to be a pull, so let's select the pull category and click the Add Part button. Placing it in the pull category will allow us to easily find this extruded pull so that we can assign the proper material to it. Let's call this Pull E, since it's a pull that's extruded. All we need to do now is rename the part to Extruded Pull, and we're done here, so we can close this out. Next, we'll want to create a new material, so we need to open the material catalog. Since we created the part as a pull, we should make the new material a pull as well. First, we select the Pull tab, then we create the material. We'll call it Extruded Aluminum. Then change the unit to per foot, because EPCO sells the extrusions and lengths that we can cut up ourselves. Now I don't want the pull to have any shape, so we need to change the shape to NA. Finally, I want to change the texture information. We don't need an actual texture, but I will use a specific color. For the heck of it, I will just use blue. Well, maybe something a little lighter. Yeah, light blue works. Finally, we just need to set the finish type. And I will select the metal matte since I don't want it to be too shiny. And that's pretty much it for making the material. We could add costing information, but I'm not going to right now. So let's go ahead and close this out. Now we have a part and a material. We just need to link the two together. That's done in the material schedule. So let's open the pull material schedule then. With that open, we're going to select the material for the first schedule. So we just double click on that part and select our extruded aluminum pull. Next, we want to fix it in the rest of the schedules as well. So we now right click on that same part and select change in multiple schedules. We will uncheck the no pull schedule as this just needs to be nothing. And then we click the change to extruded aluminum button. Then we just click the close button and leave the material schedules. So we have the part, we have a material, and we've even linked them together now. So we could now start working with the UCS to get what we want. But there's actually another step that I want to perform. And that's adjusting the reveals on the cabinets for these pulls, which means we have to create a new construction method. To do that, we just open the assembly construction. Next, we select any of the construction methods. Typically, it would be one that you would use the most, or the one that you expect to use most frequently with this type of pull, and then click the copy button. For the name, I'm just going to add extruded pull to the end. Let's pause here for just a second. You see this ID equals 20 number? This is something we're going to want to write down for later. I'll tell you why when we get to it. Next, the only thing we want to change are the reveals. So let's expand the exterior case section and then double click on the reveals section. Now we know that from the bottom of the seat part of the pull to its top is 15/16 of an inch, which equates to roughly 24 millimeters. I want an additional 10 millimeters for the reveal of the top, basically because that's what I use for my top reveals. So this value needs to be 34 millimeters. This next reveal, I typically have at 3 millimeters, so I need to make it 27 millimeters. The rest are irrelevant, so I will just fast forward through since they don't really pertain to making this work. Now we just close out of the construction method and save our changes, and we can finally start a new job. So now I'm going to just simply create a new job with our frameless extruded pull construction method selected, place a wall in the job and a simple base cabinet on that wall. Now comes the fun part, making this whole thing work together. The first thing we do is to create our library part. To do that, we have to get into the orthographic viewport of the cabinet. So we just double click on the cabinet, and it brought me to the Face Ortho viewport. If it doesn't for you, just click on the proper tab. So this is the first new feature set that we're going to use that we get with Cabinet Vision Solid Advanced. You should notice that there are a few more buttons here on our sidebar that we didn't have in Standard. First, we can import objects. If you've seen all of my podcasts, you might remember a podcast that showed off how to make a compound object. Need this to do that. Next, we have the Library Part button. This button allows us to import parts that we have stored for later use. Just like with the cabinet catalogs, we can design specific parts, or like we are about to do, import SketchUp parts, and save them for reuse. Finally, we have the CAD button, which will allow us to create CAD objects like text, dimensions, and shapes at the cabinet level. Now we want to click on the Utilities tab of the ribbon bar. You see we have a couple of new buttons here as well. The Import DXF lets us import a 3D DXF object as a part into Cabinet Vision. But we're more interested with the Import SketchUp Model button, since that's what we want. Now we just want to click on the little ellipsis button so that we can locate our EPCO DP414 model. It didn't do anything though. Well, we found the file, we just need to import it now. And there it is. So now we have to flip it. Why? Well, this is because we want the extruded pull to show up in the report center, giving us a total length to all of the pulls. So we need the Y to be 1. Right now, the Z is 1. To make this simple, I know that I have to click flip X 3 times to get what I want. Now that I have it oriented properly, I can assign the part type to it. So we click the Type button, change our schedule to Chrome 4-inch C pull, and select our extruded pull part and click OK. The part is now ready to be placed, so we can click OK again. It's in Cabinet Vision, but we don't want it there. So what I'm going to do is save it to my part library so that I can have a UCS place it in the proper location for me. That means I need to right-click on the part and select Save to Library. I can pick any library I want, but I'm just going to put it in custom cabinets. Now remember that this is where we put it for later. Now I want to rename the part to something that's unique and easy to remember, like EPCO DP414. We also want to check the Preserve Size box to make sure that Cabinet Vision doesn't alter the part size when the UCS places it. Then I click OK, and now I just delete the part that we imported. Finally, we can make the UCS that's going to put the part where we need it to go. We can just click on the User Created Standards button to open our UCS editor. You can see that I already have a UCS that places these parts where I want them. Let's check it out by clicking on the Edit button. Now this is a really simple UCS that will properly place our extruded pulls at the top of every door and drawer. Let's go through the process of creating a UCS that matches exactly what this does. Now, just to mention it, creating, copying, importing, running the UCS wizard, editing, and applying UCSs prior to build are features that are given to us by Advanced. We wouldn't be able to do this in Standard or Essential. So I will click on the new UCS button. I don't like using the wizard here, mainly because I know how to write UCSs, and using this is more of a hindrance for me. So I will just click OK. Then I will make sure that the new UCS is selected, and then click the Edit button again. Now I can just highlight and delete all of this pre-generated text and start with my own. Now a UCS is a loop. That means it continuously runs on all parts, openings, etc. of a certain type. This means that our first line needs to start with that loop. So we will be entering for each. Now we have to define the type. Because I know what we need to use, I will just type it in, DOR_OPEN, and then tell Cabinet Vision what type of object this is, an opening. So this UCS will now function on each and every door opening on every cabinet in this job. Now we can tell it what to do with these openings. First and foremost, I want to limit the use of this UCS to our extruded pull construction method. This is why we needed to remember that number from the construction methods. I start off by telling Cabinet Vision that it needs to do a check of a value, so I place if. Then I tell it the name of the parameter to check, cab.constID. Now this is the full path of the parameter I want to check for. Cab is the full cabinet object, the big parent. And when we specify this, Cabinet Vision will know to pop up directly to the very top of our object tree. The period tells Cabinet Vision that the parameter is directly below or a child of the previous name. So we're looking for the const ID parameter on the cabinet. Next we need an operator. I'm going to use an equality operator, which is just a pair of equal signs. I could use a single equal sign, but I recommend using a double one, if not just for readability. Next I have to tell Cabinet Vision what to compare with. This is where our number comes in, 20. So what we have so far is Cabinet Vision checking the cabinet's construction ID value for a value of 20. Now we have to add a then, which is basically telling Cabinet Vision if this return is true, then do something. We will immediately cap this statement off at the bottom with an end if, because all if statements must have a corresponding end if. That's the rule. Now we need to tell Cabinet Vision what to actually do. I know I want Cabinet Vision's default polls to go away, so I will use a built-in parameter named PQ, which stands for pull quantity. Whenever you create a new parameter, or specify the value for a parameter, you can also specify the parameter's type by using a pair of angled brackets and the text for the type. PQ needs to be an integer or whole number that is not affected by Cabinet Vision's measurement unit display. So the type text for this is int. Next, I need to use an assignment operator, the equal sign, and then set a value of 0. Now Cabinet Vision will remove any pulls that are assigned to the door. Next we want to create a new pull. To do that, I have to type dim, which is telling Cabinet Vision that I need to make something. Then I tell Cabinet Vision what to create. Remember when we created our part, we called it pull E. So that's what I type here. To finish off the creation of this part, we tell Cabinet Vision that it's supposed to be a new part, so I just type as new part. Now the UCS is creating a new extruded pull in each and every door opening on every cabinet that is using the extruded pull construction method. We could stop here, but you saw there was more than this in the other UCS. So we can now tell Cabinet Vision how to handle this new pull item. For legibility's sake, I typically put a single space between the dim line and the start of all the parameters for that part. So we know we want this pull to have a specific shape. That's why we stored the SketchUp model in the part library. To get that, we use the part's built-in parameter, libPart. So it needs to read pulle.libPart. Next we use the assignment operator, and then a single quote. The single quote tells Cabinet Vision that this is some text, which we will enter in as the path to our part. The path starts with the catalog's name, so we put that in the custom cabinets catalog, so that's what we type here. Next we place a backslash, and then the name of our library part. Now we name that EPCO DP414. Finally, we just close it off with another single quote. Let's get out of this UCS now so that we can see what's been done so far. This isn't just to look at it, but more so to check to see if we've gotten everything right so far. When we try to exit out of this, the UCS editor tells us that we've customized the UCS, and saving these customizations will not guarantee that the UCS will actually work. You can trust me that, for now, it will work. It won't be finished and correct, but what we have will work. So we can click yes to save the changes and then close out of the UCSs. Now we see our cabinet. If you look closely, you can see the new extruded pulls in the lower left corners of the door openings, one for each door. They aren't the right size or in the right spots. If I go to the end ortho viewport, we can see that they aren't even rotated in the correct direction. This is because of how we saved the part to the library. But this is exactly what we want right now. Before we go back to positioning the pulls properly, I want to open up the object tree to show something to you. This is important to what we're about to do. So here we have the main parent. When we specified cab in the UCS, this is what Cabinet Vision looked to. If we expand it out, we can find its child objects. Now we have the different sections of the cabinet. Since we're working with the door sections, and I know that they are located in the face section, we can expand that out. Now you see the various doors and drawers we have, separated out by openings. Let's expand a door to check it out. And there's our extruded pull, right where we want it. Now, I showed you this because we're about to use a special operator in the UCS that tells Cabinet Vision to look at the direct parent of our pull. So if we look at our pull, we can see that the parent is DOR_open. The next operator we will use is the child operator. You know, that period that we used before, which will tell Cabinet Vision to look at the child of the current object. We can then specify which child and carry on. When we specify a child, we can look to the child objects or the parameters of the object we are on. Just a small note. So let's go ahead and open the UCS editor back up and try that out. So now let's work on the Y position of the pull. This will move it up to the top of the door. So we type pull_e.y, MEAS to specify it as a measurement parameter, equals, and here's where we use the parent operator, which is a colon. Since the value or equation that we're setting is being set on the pull, we need to work using values relative to that part, hence looking to the parent. Then we immediately want to look down at a child value, so we place a period. The child we want to look at is the door, as this object is the actual door sized out to the proper dimensions for Cabinet Vision. So we then type in DOR, add another dot, and then type the Y. This will now move the pull up by the Y value of the door. The reason we did this is because the door will be placed up in the opening by a value that is relative to the reveals, in this case, the bottom reveal of the cabinet. Now, it's still not at the top of the door. To do that, we need to move it up an additional value by the height of the door, or the dy. So we enter plus parent.dor.dy. Now let's check out the placement of the pull again. Excellent. We can see that the pull is at the top. Still not oriented properly, so let's go ahead and fix that now. From experience, I know that I have to rotate the pull along the Z and Y axes to get it rotated properly. The rotational parameters are always prefaced with an A, so we need to set the AZ and AY parameters of the pull, so let me type those in. This time I use DEG as the parameter type. This lets Cabinet Vision know that the parameters are a measurement of degrees and it should handle them as such. If we go to check out our pull now, we can see that it's properly rotated, but now sits behind our door. To fix that, we just go back to the UCS and change the Z position of the pull. We set it to the DX of the part, which, because of how we saved in our library, is the thickness of the pull. If we check it out again, we can see it's lined up in the door the way I want. We just have to go back to the UCS and adjust its location to add the height of the pull and then move it down by the distance from the bottom of the pull to the bottom of the seat. We know that that value is 13/16 of an inch, so we just add to the Y equation that's already there, dz, or the height of the pull, minus 13/16. When we check it out again, we can see that it's now sitting right where I want it. Now it's intersecting the door, but it's either that or we have to move the drawer stretcher back from the face or move the door position away from the cabinet. For my purposes, this is fine. If we go back to the face ortho viewport, we can see that the door starts here while the pull starts here. To fix that, we go back to the UCS and change the X position of the pull to equal the door's X position. And now the pull starts in the same place as the door. Finally, we just have to change the length, because this pull is just a little too short for this door. Once again, we go back to the UCS. To set the length, we want to set the dy parameter of the pull to the width of the door, or its dx value. Setting the length of the pull like this will allow Cabinet Vision to give us a total length of all the pulls in the entire job. This is why we wanted the y to equal the extruded length of the SketchUp model that we saved to the library, hence all that flipping. Now we go back, and this time we go to the 3D viewport, and we can see that we have the door pulls done. But we're missing something. The drawer pull. Well, we created a UCS for the door pulls, so now we should probably go and create one for the drawer, right? Not exactly. What we're going to do is go back to the UCS and modify it so that it will work on the door and drawers at the same time. The modification is pretty simple. A door opening is DOR_OPEN. A drawer opening is DWR_OPEN. To make the UCS work on both, we just need to change the O in the DOR_OPN to a question mark. What does this do exactly though? Well, this is called a wildcard. It represents any letter of the alphabet, including numbers. Since the only difference in the name of the door and drawer openings is the O and the W, we can do this. Let's check it out again. So there it is, but it's in the very wrong place. Back to the UCS to fix that. Before we edit anything, we have to know why the pull for the drawer is in the wrong place. I know why, but can you see from this code what might be causing this problem? I'll give you a chance to figure it out. If you want more time, you can pause the video. If you figured it out, or you think you did, great. If you couldn't, here's why. There's no door in a drawer opening. For the drawer, this should be DWR, not DOR. You might think, hey, let's put a wildcard here. Unfortunately, that doesn't work. What we have to do is put an if statement below our pull that checks to see if the opening is a drawer opening. We can easily check that by checking the name of the opening. So if this.name equals DWR_OPEN, then we finish it off with an end if. Now what's this? No, really, what's this? This is a keyword that lets you make sure that the check is being run on the object specified in the for each line. So all we have to do now is change those O's to W's. So I will just quickly type all of that in. So now we have the parameters using the proper equations. So let's go ahead and check it out. Oops, I seem to have forgot to bring the pull back down from the top. Let me fix that real quick by adding -13/16 to the Y position. Okay, great. So now we have our door and drawer pulls. They are in the correct location, the correct orientation, and even have the proper length. If we go to the Report tab, let me sort these alphabetically, we can see that I have 3 extruded pulls on this cabinet. 1 for the drawer, 2 for the doors, 1 for each. I can even go to the Report Center and take a look at my job summary report, which tells me that, for this job, I need 4.95 lineal feet of extruded aluminum. Now, if we wanted to say EPCO DP414 or some other name, we would only have to make that change to the material name in the material catalog. On top of that, we can even create multiple materials in the material catalog to reflect the various finishes we would have for the DP414 pulls, giving us the proper renderings and the proper summary totals, not to mention pricing here had we entered that information. We can even look at the assembly sheet to see what pull lengths we need for the specific cabinets. Oh yeah, and here's another addition from Standard, the Report Center. In Standard, you do have the Report Center, but you only have the ability to print from a limited list of reports that you don't get to choose from. In Advanced, we get to choose from hundreds of reports as well as creating and importing additional ones. So I hope this helps you to learn more about how we can easily manipulate the basic functions of Cabinet Vision and use a simple UCS to add functionality that doesn't come with Cabinet Vision built in. Now here are some images of additional cabinets that I made by making no changes to the code and just using the section editor. This one I did have to modify the UCS to place the pulls on the bottom of the door, and I will go ahead and list out those changes in my Facebook notes. And it's that time again. Once again, many thanks to Hayfla for their continued support. I will now leave you with this quote from Douglas Adams' book, Dirk Gently's Holistic Detective Agency.